All right. Well, hello, everyone. Good morning, good afternoon, depending on where you are. Welcome to today's Pedestrian and Bicycle Information Center webinar. This is actually the first of a two-part session we're doing this week on the FHWA Crosswalk Marking Selection Guide. We're going to tell you a little bit about the guide itself today, and then we'll get into some detail on Thursday about the work that went into developing the guide, some of the research behind that. So we'll talk a little bit more about session 2 in a moment. And I'll introduce our panel. We'll get underway. I want to share a bit of information about some housekeeping first. As always, you can submit questions to us at any time during the webinar. We have a period of time scheduled at the end for Q&A, so we'll be holding those questions for the end. So do ask them when you have them. We're archiving this webinar today. We have a copy of the slides online that I'll share with you shortly. We are recording the session as well. We'll be posting that to our website. You can find it pedbikeinfo.org/webinars. We also have a live transcript for the webinar. I'll send a link via the chat shortly to that if you're looking for that resource. Later today, you'll get a follow-up email about getting a certificate of attendance for the webinar, filing professional development hours for the webinar, and all those sorts of things. So be on the lookout for that. It'll come about an hour after the webinar ends. I encourage you to review the previous episodes we've held and posted on our website, and also to sign up for the upcoming sessions. I was mentioning just a moment ago, there is a part 2 following this webinar to be held on Thursday, looking at the detailed field research from the guide, sort of the work that fed into the guide. So in a moment, I'll send you a link to register for that webinar. It may be that you've only registered for this one. You might find a lot of interesting information. We think you will in the part 2 to be held on Thursday. Let me tell you a bit about our panelists that we have with us today. First, we're going to hear from Mike Alston, who is a senior engineering associate based in Oakland, California, with Kittleson and Associates. Mike has direct experience conducting transportation research and applying that research to the local context. We're also joined by Sarah Brown, who is a transportation analyst at Kittleson and Associates in the Wilmington, North Carolina office. Sarah has a passion for mobility justice and integrating equity further into the systems and foundational practices of the transportation sector. We're also joined by Bastian Schroeder, who is a senior principal engineer for Kittleson based in Wilmington, North Carolina, and serves as the firm's director of research and innovation. As a recognized leader in transportation industry, he helps guide transportation emerging trends and technologies. We are also joined today, you'll hear briefly from Darren Buck from the Federal Highway Administration, who oversaw a lot of the research and work that you're going to be hearing about today. So without any further delay, what I'll do is hand the screen over to Mike. It's coming to you. I'll let you know when you're up and running. Perfect. I've got your slides, Mike.
Great. Thanks. Bastian, you want to take it away?
Yes, good afternoon, everyone. Good morning. Thank you for joining us today for, as Dan mentioned, the first part of our webinar on the forthcoming crosswalk marking guide for Federal Highway. Our focus today will be more on the big picture takeaways, the you might say policy level implications of the guide, and then we'll follow up Thursday with more detailed information on the experiment, the data collection, some of the statistical modeling. Before we jump into it, I'd like to hand it over to Darren Buck with Federal Highway Pedestrian Bicycle Program Coordinator for the Office of Human Environment to share Federal Highway introduction. Darren? Thanks,
Bastian, and thank you, Dan and PBIC for getting this set up and for your colleague Sarah Bryan's work on this, and to Mike, Sarah, and Bastian with Kittleson, who did a great job on this product, which is still ongoing. We are working on sort of getting final reviews through and getting everything buttoned up, and we expect to have this guide, the complete guide, finalized by this spring. But we wanted to make sure that we were able to get some of the overview of what's been accomplished so far out into the public sphere now. The team did a great job of, frankly, adjusting course multiple times throughout the life of this task due to the COVID-19 pandemic and many of the complications that I'm sure many other research teams have encountered over the past 2 years in doing field data collection. But we hope the outcome of this is a guide that helps advance pedestrian safety with some new insights some new guidance and helps us all advance the Secretary's new National Roadway Safety Strategy. Without further ado, I'll pass it back to Mike and Bastian.
Thank you, Darren. So I wanted to start by acknowledging the project team. Really, the overall coordination of this is done by Cadmus with Pierce Schwab out of Alaska, really managing the most of the day-to-day on the project. Sarah O'Brien with HSRC and myself are kind of co-principal investigators on the project, and also working very closely with Mike and Sarah on the Kittleson side, who you'll hear from today. And then also really crediting Taha Salim with HSRC and really helping on a lot of the statistical modeling and data analysis, plus many other staff and really all three entities that have helped on data collection and different parts of the guide. So our plan for today is really give you the big picture overview of the guide purpose and organization. I'll then hand it over to Sarah to talk a little bit about the state of a practice, some of the research and outreach that we have done. And then Mike will summarize some of the original research we have done and really go into the recommendations of the guide. Again, we're going to keep it at a pretty high level. What are really the implications for agencies, state and local agencies across the country, following up Thursday with much more details on the field experiment and other implications. So starting with the guide purpose and organization, our focus and the focus of this draft guide, again, it's not out yet, we're hoping it will be out later this year, is really talk about the purpose of crosswalks, what their documented benefits are, and what are the factors to consider when selecting marking designs. So specifically, continental markings versus high visibility markings, ladder markings, really different variability and variations of crosswalk markings. This is not a guide on whether or not to mark the crosswalk. So there's other resources in the MUTCD, other research that's looking at that. It is really trying to answer the question as once you have a crosswalk, what type of marking is really most appropriate, and looking at that from an effectiveness perspective on driver yielding and visibility, but also take into account cost and maintenance implications. So you'll find all that in the guide. So in the guide, you'll find really agencies finding support for decision making when it comes to selecting crosswalk markings. It considers, different aspects, as I mentioned, related to markings. So the safety, the yielding behavior from drivers, the visibility, the overall effectiveness, what are the material maintenance and cost implications. And really what you'll find in the document is a combination of a lot of existing research, so state of the practice and literature synthesis on research by others that is all pulled together into this one document, plus quite a bit of original research, really looking at 16 crosswalks in 4 different states, and really doing some very controlled yielding studies and driver behavioral studies in kind of paired comparison of different marking styles that we'll share a little bit more in a few minutes. And so with that, I'll hand it over to Sarah to share a little bit on what we learned in the state of the practice assessment of the research.
Yeah, thank you, Bastian. And yeah, I will walk us through some highlights from the state of our practice that we explore in more depth in our guide. But I wanted to begin talking about crosswalks, but really the core function of them and the context behind why we mark them. So crosswalks are areas where pedestrians are granted the right of way when crossing a roadway. Crosswalks may be marked or they may be unmarked. And in most cases, crosswalks marked or either unmarked exist as extensions of the sidewalk network at intersections and grant the right of way to pedestrians crossing the street. But why do we mark them? Crosswalk markings are traffic control devices, and they serve several core functions, including alerting drivers to pedestrians' potential presence in the right-of-way. They establish the pedestrian right-of-way at mid-block locations. And in states that follow the Uniform Vehicle Code definition of an unmarked crosswalk, they establish pedestrian right-of-way at crossings lacking sidewalk connections on both sides. And lastly, they provide wayfinding cues to pedestrians with low vision. I wanted to expand more on the low vision aspect. Crosswalk markings provide an assistive function for pedestrians with low vision to guide them. There's no published research that compares the effects of different marking designs on street crossing by pedestrians with low vision, but orientation and mobility experts transverse lines as a visual distinction from the pavement. And the contrast between markings and pavement can assist pedestrians who have low vision with critical wayfinding tasks, such as finding the crosswalk, aligning to cross, maintaining proper alignment during crossing. But crosswalk markings do not provide a wayfinding benefit to pedestrians who are blind. So here's a summary from the MUTCD for the names and the types of crosswalk markings. The terminology and the MUTCD has also been used for this guide. So lines that are striped parallel to the direction of vehicle travel are referred to as longitudinal lines, and those parallel to the direction of pedestrian travel are referred to as transverse lines. And this guide refers to the two transverse lines alone as a basic crossing, and any design that incorporates longitudinal or diagonal lines as high visibility crossing or an HVC. And practitioners should refer to the current version of the MUTCD for the latest standards and guidance for these crosswalk marking designs. I did want to touch on intersection and non-intersection locations with crosswalks. So as we've already explored, crosswalk markings are traffic control devices that indicate the area for pedestrian crossings. And at intersections, marking the crosswalk delineates the designated pedestrian path from one street corner to the next, but does not alter the pedestrian right-of-way within the space. But at non-intersection locations like a mid-block, crosswalk markings establish a location where pedestrians have the right-of-way when crossing the road. And in some states that follow the Uniform Vehicle Code definition of a crosswalk, an unmarked crossing does not exist at an intersection when neither side of the crossing has a connecting sidewalk, and pedestrians would not have the right of way when crossing at these locations. But there are local variations that exist within this. So getting into some of the safety aspects that we cover more in depth in our guide, existing research from our literature review presents mixed results on certain safety effects of marking crosswalks, with the takeaway that context matters. The two most common outcomes that measure safety effective crosswalk markings are pedestrian vehicle crashes, which can be seen as a direct measure of safety, and driver yielding or stopping, which is an indirect measure of safety that also can affect perceived safety. So looking at cross risk, there really is no conclusive findings on cross risk. Safety outcomes appear to improve with the application of marked crossing locations on narrower roads, but appear to degrade along wider, multi-lane, higher volume, and or higher speed roads. In summary, US and international findings point to the variable effectiveness of marked crosswalks on crash risk in relation to other factors. Then looking at yielding, research has shown a large variance in yielding rates across sites and contexts, but there is a clear inverse relationship that exists between speed and driver yielding, with higher speeds resulting in reduced yielding propensity by drivers. Research has shown yielding rates is negligible and becomes more negligible at sites with high speeds over 30 to 35 miles per hour. And research also has found that yielding rates are influenced by several factors, including roadway characteristics, site context, and a growing amount of research has also been showing disparities in yield rates based on perceived race, gender, age, and socioeconomic status of both the driver and the pedestrian that impacts yielding. But again, kind of wrapping this up, no conclusive findings on crash risk. And with yielding, there is an inverse relationship that exists between speed and driver yielding. But yeah, I wanted to touch on visibility because visibility has more conclusive findings. And a rigorous FHWA field visibility study found that HVCs are indeed more visible, and drivers detect continental markings at a mid-block crossing about twice the distance upstream as the transverse markings during daytime conditions. Daytime detection distance was longer than nighttime detection distance, regardless of location or marking type. And this slide is just demonstrating this with the basic marking above and the HVC below that were taken from the same distance on the same roadway to demonstrate an example of the differences in visibility. But again, yeah, research has shown HVCs to be more visible from twice the distance of basic. And with that, I'm going to pass this over to Mike to go over our original research.
Thanks, Sarah. Just real quick, Sarah, before you go on mute, can you hear me?
Yep.
Okay, great. So Bastian laid the predicate for what this guide is set out to accomplish, and Sarah succinctly described what we learned over the course of a several-month literature review. I think, as she pointed out, we know that speed matters, and we know that there's really hard or equivocal evidence on what the actual effects are from a safety and a yielding perspective, and we know that context really matters. So that really paved the way for us to think about what original research we could do that would benefit the guide and provide recommendations. And really starting from the standpoint of, with the mixed level of information that we have out there, recognizing that agency practices are also mixed. The previous slide was actually two successive crosswalks on the same road in one of the jurisdictions we did field research in. So, you know, all else equal, one of them ended up with a basic crosswalk marking and one with a high vis. And so that practice is allowed within current federal guidance. So what original research could we do to help shore up recommendations and give agencies a more consistent approach for how they mark crosswalks? So we started out with a couple key research questions from the gaps that we recommended, or the gaps that we saw. And the first question here is, does the increased visibility of high vis crossings, HVCs, lead to increased effectiveness? So we do know with certainty from an FHWA field study that they're more visible from twice the distance, but we haven't conclusively found that they always reduce crashes or always improve yielding. So given that, what can we actually say about their effectiveness, and how much confidence do we need to have to make a recommendation? If they do have increased effectiveness, where are they recommended? Or put more succinctly, why not use high vis crossings everywhere for all marked crosswalks? The second question of interest was, what are the agency criteria for selecting marking types, and what should be included in guide recommendations? So we were interested not just in going out and finding some objective truth about the exact contours of the benefits that high vis crossings provide. We knew we wouldn't learn everything there could be to know. We also wanted to learn from agencies. What have they learned through practice, and what are some best practices that we could adopt and apply? So in the next 20 or 25 minutes, I'll discuss the field research that we did, the original field research, and where we landed and how that informed guide recommendations for marking. And then I'll pass it back over to Sarah to talk about some agency interviews that we did. So a second piece of original research that really informed this second question. So it was nice to be able to go out in the field, collect some original data for this first question, and then talk to agencies throughout the country about what their practices are and what their local knowledge is to inform this second question. So there's a lot to say about the field research we did, so much in fact that we scheduled a second webinar for Thursday. So I'll give you the high level overview here, and then I'm gonna have to leave some details on the table, I'm gonna have to leave some details for Thursday. So again, the field research, we sought to evaluate yielding behavior as our measure of effectiveness. It was simply more practical within the bounds of this project to study yielding behavior than to try to do some sort of longitudinal crash outcomes approach. So that was the first basic decision we said is, let's measure effectiveness through yielding behavior. We targeted similar sites. So I mentioned before that often the same road will have very similar crossings, but different applications of marking types, which makes for a perfect experiment. We sought to go find locations that were 2-lane, uncontrolled intersection crossings, generally outside commercial and urban core areas with relatively low speeds and volumes. And at these sites, we conducted staged pedestrian crossings. So in all, we found 32 sites, half basic markings and half high vis markings. And you can see an example here from some of the pilot work that we were doing to test our methodology. This is a high vis crossing site. So then we found these 32 sites and conducted a controlled stage crossing. We established an internal protocol for crossing consistency. So pedestrian, body language, influence area, et cetera. So let me say a little bit more about that. We took 2 folks out into the field and recorded all of our sessions. We just strictly defined before we went into the field a dilemma zone. So we would approach the crossing and get to the corner like you see here, such that drivers still had enough time to yield, but didn't wonder why we didn't cross already. The original plan pre-pandemic was to actually fly me to the various locations throughout the country to do this so we could control the pedestrian exactly. But 2020 and 2021 upended those plans, and we ended up finding ample doppelgangers to help me out. And so we basically wore the same outfit, had the same general look from a couple hundred feet. So we were able to control for that as well. And then we found, as I mentioned, 32 total sites. So that was 8 sites in each of 4 locations in and around Portland, Oregon, Oakland, California, Orlando, Florida, and Raleigh, North Carolina. And then lastly, what kind of innovative part was not just to conduct stage crossings, but to actually take the camera and radar out so that we could collect vehicle volumes and speeds for the duration of these observations. So that way we would think that we were finding low volume and low speed sites. We'd go out in off-peak hours, and then we could actually confirm what the speeds and volumes were. Again, so much to say here, but I'll leave it with, we found some variation in our sites. We generally found sites that were 25 or 30 mile an hour operating speeds, but actually had a few that ended up a little higher. And we ended up with 1,200 total crossing observations to analyze. This next slide shows a comparison site. So these are in and around Orlando, Florida. So this is on the left here is a basic crosswalk site. On the right is a high-vis crosswalk site. So again, kind of a nice natural ability to experiment with a road that's the same road, about a quarter mile apart, a slight change in context, and then different crosswalk marking applications. So this is what we tried to do, is find sites that, to the extent possible, were all else equal. We did note some variables that we couldn't control for, and we'll talk more about those on Thursday. But now the fun part, what did we actually learn? So from those 1,200 observations that I mentioned, we were actually able to do some modeling, and we were able to build a model to understand how drivers behaved. And so the results from the 1,200 crossing observations allowed us to build a model that used all the inputs we observed and modeled driver yielding behavior. And I think this chart is worth 1,000 words here. It demonstrates the relationship we observed. So let me explain. We have 2 curves here that represent all of our observations fit to a curve at basic sites and at high vis sites under certain conditions. And it demonstrates the relationship we saw. So at the extreme low end here, sites where a driver is approaching a crosswalk at say 15 miles an hour, we'll observe something like a 4% difference in driver yielding behavior. Move that along to something like 25 miles an hour and the difference grows, still a higher yielding percentage at the high vis sites, but a larger difference between the two. And then Sarah mentioned this actually from the literature review findings previously. Once we get to the far end on the right here, where drivers are approaching a crosswalk at say 40 miles an hour, the difference shrinks back down to 3%. So again, these are regression curves based on the 1,200 crossing observations we had, where we had a driver's maximum approach speed and we observed whether they yielded. And so the big takeaways from this slide are, at high vis sites, driver yielding improved. But speed was pretty much a swamping factor that really had, across all the models that we built, a stronger and more pervasive effect on yielding behavior. And that's really consistent with what we found in the literature. So again, thinking through this, what are the implications for the guide? Well, I've got 3 buckets here of findings. And so these are essentially what we were able to say from the models that we built and tested. So the first one here, I mentioned speed already. High-vis crossings have a strong positive effect on driver yielding, so long as 85th percentile speeds were less than 30 miles an hour. This is both true in what we observed and a function of the sites that we found. So I mentioned we were working with low speed and low volume sites. So we did see a positive effect on driver yielding from high vis. That can't necessarily be applied to 45, 55 mile an hour sites. That's beyond the bounds of what we studied. We did also, I mentioned, we had some variables we could and couldn't control for. Some of our sites had warning signs at the crosswalks, the W11 or S1 variety, and some didn't. So that allowed us to include those in the model as well. And we found that HVCs, high-vis crossings, had a positive effect on driver yielding with or without those signs present. And then lastly, the site context. I mentioned this already, but some of our sites were at the higher speed end and some were at the far lower speed end with 25th or with 85th percentile speeds, or hovering around 25 miles an hour in a dense grid street network. And there, high-vis actually lost their effectiveness to improve yielding. So we did find some positive results for high-vis crossings on driver yielding, but there were some bounds to that. So let me translate that a little bit more. High-vis are associated with increased driver yielding compared to basic. Going back to the previous question of if they're more visible, are they more effective? This points to yes. Yielding rates showed robust negative relationship with driver speeds. So irrespective of the markings, when a driver was approaching at a certain speed, they were far, far less likely to yield. And we saw that in the model, and we talk about that more in the guide. So speed is really the king here. High-vis effectiveness, strongest with lower driver speeds. And for our purposes, that was 85th below, at or below 30 miles an hour. And lastly, high-vis show positive effect with and without supplemental warning signs, although a slightly stronger effect in the absence of warning signs. So then what do you do with this information? Well, we get into this more in the guide, and this is just a preview, so we'll talk more about it in the guide, which, as Bastian mentioned, is hopefully later this year. But in summary, high-vis have a yielding benefit. Driver speed has a stronger relationship with yielding though, and context definitely still matters. I mentioned this before, but we really tested sites that were 2-lane, relatively low volume roads. And when I say low volume, I mean in the hundreds of vehicles an hour when we were out there. So high-vis markings are not a panacea. They're helpful, but they're not sufficient in most cases, or in many cases rather. So let's talk about how we translate that into the guide recommendations. To put it simply, when should high-vis be used? Well, based on what we read and what we learned from our original research and from the agency interviews, which Sarah will talk about in a moment, they have the potential for yielding benefits in crash reduction. If a crosswalk is worth marking, it's worth marking as high-vis. We know they're more visible, and we've seen in various cases an improvement in yielding behavior. So we recommend them over basic patterns for anywhere you mark crosswalks. Now, you might be thinking, well, surely there's some edge cases that might apply, and we'll talk a little bit about cost, maintenance, materials considerations, but this second bullet point is really the takeaway from this hour that you're spending with us, is that we think the potential benefits and the documented benefits of high-vis in certain scenarios render them useful over basic crosswalks. So what do I mean high-vis? These are the basic designs that we're talking about. So we have the double pair, the bar pair, and we have the longitudinal bar. Sarah mentioned earlier a possible wayfinding benefit that hasn't been documented but anecdotally shared by orientation and mobility specialists, and that's putting the transverse marking along the edge there. So that piece is optional. That's agency preference, recognizing that that's more prone to wearing away than the longitudinal lines, especially given that the longitudinal lines can be positioned to avoid tire tracks. However, marking is not always enough. I think we knew that coming into the guide, and some of what we saw in our original research reinforced that. So given that, well, what else do you do? And here I'm showing that W11 warning sign we mentioned. Well, consider roadway configuration, speed, and volume, and consider pedestrian demand and delay. There's another whole webinar we could give on that, but we talk about that in the guidebook, and we refer to some other guidance. And here's one that many of you might be familiar with. This is from the Guide to Improve Uncontrolled Crossing Locations. And so what I'm showing here is a, 9x5 grid. So there's 45 possible configurations of vehicle volume, speed, and roadway configuration. This red rectangle shows you the sites that we studied. So again, a narrow portion of possible sites, but we thought a valuable portion of possible sites, given that those are locations where crossings alone might be used. Outside that red rectangle existing guidance has already indicated crossing alone might not be enough. So we're not going to reinvent the wheel here, but we'll point you to other guidance that can tell you what else to do. One more note on this chart, which has such an incredible depth of information, is you'll notice here on the bottom right, it says high vis crosswalk markings. That's number 1. That's included in all cells as a consideration. And then they also typically recommend other treatments with it. So our research doesn't negate that at all, but it says when you mark crosswalks, high vis is probably the way to go. There's a lot more existing guidance for high vis use and for additional treatments. So those are listed here. And then the last piece to discuss before I hand it back over to Sarah to talk about agency interviews and recommendations from that is to consider social equity and when prioritizing investment and selecting supplemental treatments. And so Sarah mentioned earlier that existing research has actually documented the socio-demographic effects of yielding. And there's also a body of research that documents the disparate geographic location of infrastructure investment. So we know that high-vis markings are beneficial. Our guide recommends using them, and we also say they're helpful but not sufficient. And so we recognize that and recommend in the guide to consider these factors when selecting supplemental treatments: the quality and presence of existing transportation infrastructure, especially as it pertains to BIPOC and low-income communities, the disparate socio-demographic effects on yielding. And then lastly, and Sarah will talk a little bit more about this with maintenance, but avoid responding to public comment and requests, because we know that those aren't evenly distributed or equitably distributed in communities. So if markings are worn or supplemental treatments are requested, to layer in some social equity prioritization and consideration rather than simply using public comments and requests. So a lot covered there, and there's more detail on everything I just mentioned to be included Thursday. So I hope to see you in 48 hours, but in the meantime, Sarah will talk about materials and maintenance.
Yeah, thank you, Mike, for laying all that out for us. And for the rest of the presentation on the guide, I'm going to go through information that we synthesized on materials, maintenance, and cost that we got from our agency interviews and our questions. A key finding of this guide's interviews is that the application and maintenance trade-offs of marking materials typically govern agency decision-making rather than the marking designs themselves. So here are examples of materials used for crosswalk markings the agencies shared with us that are explored in more detail in our guide. Just for example, paint. Interviewed agencies generally agreed that paint lasts no longer than a year or maybe one winter season in a cold weather climate. Minnesota DOT's guidance indicates that paint can last longer than 1 year for crosswalk locations and low volume locations and when the markings are recessed. Another example is thermoplastic, and the reported durability of thermoplastic before needing refreshing was as low as 2 to 3 years in high volume locations. But most interviewed agencies using thermoplastic reported that markings usually lasted 5 or more years before needing refreshing. And a few agencies even said that thermoplastic could last 10 to 15 years before needing to be replaced, depending on traffic volume. We also asked agencies what they consider when selecting materials. There were a lot of considerations, no uniform criteria, but some considerations that people told us included job size, traffic volume, environmental concerns, the time to the next planned pavement preservation project, material costs, among others. We also asked agencies for any more information they could provide on how they select their materials, not their markings, but how they select their materials. This is an example of a selection matrix for transverse markings used by Minnesota DOT. And this matrix incorporates Minnesota's needs for winter weather durability, and other agencies might use a different set of criteria that consider conditions within their own jurisdiction. But for Minnesota, they look at the roadway surface material and traffic volumes to help guide some of their decision-making on materials. And this selection matrix looks at volumes that are less than or greater than 1,500 ADT to help them make some of their decisions depending on roadway surface material. Here are some material and application recommendations for different site characteristics that we go through in greater detail in our guide. But for example, HVCs have a recommendation of anti-skid properties into marking material, and high volume locations have a recommendation for durable markings and to consider recessed markings. Agencies that perform their own pavement marking have materials they work with for different marking applications, and they can be applied using the equipment that the agency has available. In other cases, agencies may contract out pavement marking and will typically specify the desired properties. As a result, again, there is no one answer to material selection for marking crosswalks. So we got a lot of answers from agencies around marking design and wear. I thought this would be interesting to include that agencies using crosswalk designs that place the markings outside of the typical vehicle wheel path, like a longitudinal bar or double paired, report that markings lasted longer than with other designs. So at the top, with basic markings, you see the tires consistently wearing down the markings. In the center, with longitudinal bars, it may be placed so that the typical wheelbase does not impact the markings. And at the bottom, with perpendicular markings, same thing may similarly be placed to avoid the most common tire tread path. So once a crosswalk has been installed, markings may need to be touched up or refreshed to maintain visibility until the next scheduled pavement resurfacing project occurs. So there is marking maintenance, and the frequency at which markings are refreshed may vary among interviewed agencies. Typical schedules for refreshing markings include ad hoc as needs are identified, on the same schedule as an inspection program, but only if a crosswalk needs refreshing, or maybe on a fixed schedule with all markings refreshed at regular intervals. And one agency refreshes even annually. Some agencies prefer to replace rather than refresh. Several interviewed agencies using thermoplastic markings prefer to grind out old markings rather than add new thermoplastic on top of the old. Other reasons for replace rather than refresh can include unit costs, mobilization is more efficient for larger projects, or traffic control is needed regardless of if it's a refresh or a replace. So getting into some of recommendations on what I have shared so far. So designs that incorporate longitudinal elements like longitudinal bar or double pair can place the markings outside of the typical vehicle paths to improve the marking's longevity. Also, regularly scheduling inspections or having an asset management system are good options when looking at maintenance. Staff observations and public input, like Mike talked about, are supplemental means of identifying crosswalk markings that require maintenance sooner than expected, but relying solely on requests can lead to an inequitable distribution of maintenance work. Got to think about who has time to submit requests, who has access to this. Those are all considerations that are important on the equity conversation. And lastly, replacing markings can be as cost effective as refreshing them. So the last thing I'll share is some stuff about costs. Agencies shared installation costs, and again, there are a lot of factors at play and no one answer. This is also explored further in our guide, but some examples include traffic control, removing old markings, the labor to install new markings, and the crosswalk length and width. Given all these variables, it is difficult to provide exact cost estimates for installing new crosswalk markings. However, there are comparative installation costs of basic and high visibility markings. And the costs in this table present relatively wide ranges, but the cost difference has the potential to become significant when summed across a jurisdiction's marked crossing locations. And from this perspective, a life cycle cost analysis may make the difference in determining whether HVCs are more cost effective. So wrapping it up with maintenance and life cycle costs that we were able to gather from the state of the practice, agencies interviewed while preparing our guide generally agreed that it cost as much to refresh a crosswalk as it costs to replace it or install, primarily because of the mobilization, traffic control, or other labor costs involved. And no research is available to quantify the effect of longitudinal crosswalk markings on reducing the need for maintenance. But agencies interviewed while developing this guide report anecdotally that longitudinal bar or double paired designs require less maintenance than basic crosswalks. And the life cycle cost is driven largely by costs to install the crosswalk initially and the number of times the crosswalk will need to be refreshed before the next time it is replaced. And this can be a function of the pavement marking's durability and how frequently pavement resurfacing occurs and traffic volumes. But other costs to potentially consider include initial equipment costs and traffic delay. So yeah, that wraps up our overview of our guidebook. And yeah, thank you all for attending. And I know the team was really excited to share this research and get this out in the world. And we are happy to open it up for our Q&A session.
Great, thank you so much, Sarah, and for the rest of the team for presenting that information. I'm gonna just move the screen quickly back to my end because I have some contact information up in case we don't get to your questions. I'm hoping that you can get in touch with us or find the information through email, maybe on Thursday, because we have a lot of questions. So I'm going to get right into them here. There are a lot of questions about some of the data collection, and we may want to punt this for Thursday. You all can tell me some more detail about when you collected data on yielding. What were the times of year, the conditions, maybe times of day that the data were collected in or under, and the types of settings where the data were collected? Are these like dense downtowns, suburban areas, maybe a mix? So I wonder if you all can elaborate on any of that.
Yeah, this is Mike. I'll try to have it both ways. I'll answer those specific questions and then say there's so much more to share both in the guide and Thursday. So definitely, whoever asked that question, I would strongly recommend tuning in Thursday. But the specific questions were related to season and time of day. So all the collection was done in late spring and summer in clear conditions, so no rain, and in off-peak conditions where there was relatively little vehicle platooning. With respect to the context and the locations, the specific need that we targeted for locations was, as I mentioned, mainly focused on roadway geometry, so 2-lane undivided intersection crossings with no supplemental treatments. But then the added layer of context was outside urban core. So we actually did look at some sites along commercial corridors, and we decided that those are less well served for this research, and we wanted to go with locations that we actually used some context classification measures and compared our sites against them to make sure that we weren't in locations that would generally be considered high pedestrian. So in other words, we really wanted to find places where drivers aren't all the time constantly expecting to slow down and stop and yield, and just made sure that was true of all the sites we looked at. So I think I answered all those specific narrow questions, but again, Thursday we'll go into a lot more detail there.
Great, thank you for that. And I imagine on Thursday we'll go into some more detail about the actual procedure of the stage crossing, because that's pretty interesting to maybe learn more about. The one question that came up a few times, I wonder if we could handle today, is whether at the point of yielding or measuring whether a driver yielded, was the pedestrian physically in the crosswalk or sort of outside on the edge of the curb beyond the crosswalk, kind of waiting to enter the crosswalk? And is that an important distinction for this type of data that you were collecting?
This is Mike again. I'll again answer the question specifically and then invite Bastian and Sarah to pull back and give a broader perspective if it's helpful. So specifically what we were trying to do, with a staged pedestrian crossing is trying to make it as natural as possible. And it actually took a little bit of trial and error with a couple pilot phases. So as I mentioned before, the first thing we did was figure out what's the dilemma zone based on the expected speed. So we want to arrive at the crossing when there's enough time for a driver to yield, but not so much time that they're just going to assume that we could have crossed the road anyway. And that's the key point, is actually arriving at the crossing. So we also had to bake in the time to approach the crossing. So there were some locations where it was just several hours of like hiding behind a tree and then approaching at the right time, which is kind of a weird thing to do, but it's all for the benefit of research. And then with respect to where we stood, again, the goal was to be as natural as possible. And so I think I showed it in the picture, but it would typically be like 1 foot, like more or less on the ramp, but with 1 foot in the roadway, and then holding still and making eye contact with drivers. So no flinching, no stepping into the street, but really just trying to be as naturalistic as possible. So I hope I answered that question. And then Bastian and Sarah, if you wanted to talk about anything else on that question?
Yeah, so this is Bastian. Just to maybe in interpreting the question a little bit, we're very much aware of the difference in state laws and statutes that refer to yielding as, yielding to pedestrians at the crosswalk versus in the crosswalk. Also the differences between yield and stop states. So some states, yield to pedestrians, others say stop to pedestrians. So really all combinations of in and at and yield and stop exist somewhere in the country. Really for us and for our study, really the key message is consistency, right? So we were less interested in studying whether more assertive pedestrian behavior would change the yield response. We've done that in prior studies actually, and we can point to those a little bit, and it does make a difference. But most important for this project is to really control as much as we possibly can, and to really then be able to isolate the effect of the marking style and being able to still quantify an impact of the marking even after controlling for the speed, which, if that wasn't obvious in Mike's big takeaway slide, speed makes a really big difference when it comes to yielding to pedestrians, and when the speeds get too high, then really, regardless of behavior and regardless of marking, we see very low compliance.
No, thank you for elaborating on that. And I think we'll probably get into some more detail about the data collection specifics and the procedures on Thursday. There were some questions related to materials that I wanted to get into. And Sarah, I think you had mentioned some discussion of using recessed markings to possibly improve the longevity of the marking itself. But there are some questions about I guess with respect to the recess, but also any kind of really raised marking and the impact on accessibility for those in wheelchairs or those who are blind. I don't think that you looked at that broadly as part of this study, but I wonder if in the literature review or in any of the interviews with agencies, this issue came up, and if you're learning anything about efforts to improve accessibility with pavement surfaces while also increasing visibility to crossings. Whoops. You all are muted if anyone's trying to speak up on that one. Not to put anybody on the spot.
Yeah, so Dan, the question is about the essentially the tension between possible visibility improvements and accessibility impacts of recessed markings.
Yeah, either recessed and then broadening it out, maybe anything that's especially raised from the surface to cause, to possibly interfere with travel path and cause a person in a wheelchair possibly to have to roll over a bump or a raised surface. I think it seems like a push and pull, a trade-off that it happens a lot in a lot of pedestrian and bicycle improvements. And I'm wondering if you all looked at any of that specifically in this research.
So Mike, if you like, I can jump in there because we really didn't look at that specific accessibility question in this research. But what we know from other projects is that the marking alone is not a reliably detectable wayfinding aid. So when Mike talked and Sarah talked about the potential benefits to pedestrians who are low vision of a ladder style marking or a longitudinal bar, that is really for pedestrians who maybe have some vision but have some vision disability but still have some vision. The key for someone who's fully blind, the marking alone is not reliably detectable. So there's other research ongoing and that has been completed also on looking at other tactile surface treatments. So there's the detectable warning at the street edge. There's also what's called TWSI, tactile wayfinding surface indicators. And there was a whole body of research with some publications that also looked at other treatments to help with locating the crosswalk and maintaining aligning during crossing. And they include both pavement-based application, meaning raised wayfinding strips, or audible signals. So using the far side locator tone of an APS device or other audible device to help with some of the wayfinding. So it's kind of a long way of answering that really, regardless of marking, whether it's recessed or on top of the pavement, it really isn't a reliable wayfinding clue. And it further was not part of this specific project.
Thanks for that. A few questions. This one was presented by a few people in different ways. One person asked about that we know that there can be some sort of glossing over of roadway signage when we have too much sign, maybe sign clutter. And they asked about whether it's possible that there can be too many high visibility crosswalks, and that kind of lessens the impact of each individual one. Another person kind of asked the question in a way that on your study sites, did you notice whether it had a difference if a corridor had a lot of these high visibility crossings along the corridor at the study site versus maybe not very many? So I don't know if those were collected. This idea that there can be too many signs, or if they're overused, maybe they lose effectiveness. Was this something you all looked at in your research as part of this project?
Yeah, I'm happy to jump in there again. This is Bastian. So we didn't specifically look at it, but we did look at the question of whether any research has been done to that effect, this notion that somehow the effectiveness of a marking would wear off from overuse. And there's really no evidence from it. We've tried to figure out where that comes from, but it really feels a little bit like an urban myth, frankly. It's the effectiveness of stop signs or red signal indications don't wear off because we have too many stop signs, right? It's a traffic control device that is intended to convey, a crossing location, or that is intended to actually establish legal right-of-way in a mid-block application. And so in order for that traffic control device, that marking to be effective, it needs to be visible. And the high visibility markings are just more visible to the drivers approaching, and actually they're more clear to pedestrians in many cases as well. So it's a little bit of maybe an urban myth. We've heard it a lot in the in the agency interviews on that is a concern, but we just really haven't found any evidence. And in asking them follow up on has this really been studied and evaluated, we really have come up empty. So it was this particular focus that we were able to look at really in our study, but we have no evidence to support that concern.
Yeah, this is Mike. We did have some fun and spirited discussions on that point several times throughout the project. I have nothing to add to what Bastian asserted, only to say that Sarah Bryan with HSRC is actually looking at, is helping to lead a study that includes that as part of its aims with the North Carolina DOT. So I would say stay tuned to HSRC for more about that. I think they are studying that question, even though we didn't.
Thanks for that. So a few questions that came up related to this. This is probably always comes up. I don't know if this is maybe outside the scope of your research, but a lot of questions of interest in artistic crosswalks, possibly placing artwork in maybe some what we consider non-traditional high visibility markings within the crosswalk area. I didn't see that you all studied this question as part of your yielding data collection, but possibly was there anything in literature that you looked at, or anything to make a case for or against, or maybe neutral on artistic crosswalks, possibly as placemaking strategies or other ways to improve safety?
So this is Mike. I'll say maybe I think I'll say three things about that. One, in our lit review, so the first thing is in our lit review, we did look into that a little bit, and we found that there's, as the person asking the question no doubt knows, there's various permutations of what artistic crosswalks are. Some that clearly fit within what FHWA allows, and then some that really deviate entirely. And then the one research finding that we could see domestically was that a pattern. There was a pattern that essentially had a 3D effect that made it look like the crossing was like coming out from the ground. That was found to distract drivers and had a negative impact. I don't remember exactly what the finding was, but that was the one piece of definitive research that we were able to find about the artistic crosswalks. The second thing I'll say is that FHWA is currently studying that separately. So it was really just beyond the scope of our work. And then it appears I only had two things to say about it.
Yeah, no problem. Thank you for that. This might be a third thing you could say about it. I don't know. And Sarah, you got into some information about materials, but there were a few questions about whether the high visibility markings possibly were compared to the use of like any stamped concrete or pavers, or that like brick look crossing. I don't know if this research studied that, or possibly that was element of the literature review as well, just comparing the effectiveness and visibility of those types.
Yeah, this is Sarah. We definitely had to limit our scope for this research project, and we did not study that.
Cool. Yeah, understood. Thank you. Thanks for clarifying. I think we have time for maybe one more, and there are numerous questions about whether the findings from some of this research and the guidance, to what degree they could be applied to selecting crosswalk markings at either signalized or stop controlled intersections or locations. Obviously, we're talking here about unsignalized or unmarked or uncontrolled crossings, I should say. But agencies are also grappling with, do we use the high visibility marking at our signals, at our stop control crossings? Could you all say anything about that or provide guidance on maybe that question?
Yeah, this is Mike, and I'll try to succinctly answer that. It's a great question. And again, I think I showed that 9x5 grid of possible locations, and that was just uncontrolled. So we really had to limit what we studied directly. But I think the closest thing I can come to from our field research that could point in the direction of that is to say we did notice that high-vis crossings had a positive impact, had a positive effect on yielding, with and without warning signs. And so those are a supplemental treatment. They're not a traffic control device. So we can't extrapolate that fully to say, yeah, therefore we know it will help at signalized intersections as well. However, the research question that we posed was, hey, if there's a benefit, why not do it everywhere? And so that's kind of where we landed, is unless an agency knows something that we haven't been able to find about the cost or maintenance considerations, why not do it everywhere? So we recommend that for that reason. There's, as Sarah mentioned, several benefits of crosswalks. Driver awareness is one, pedestrian awareness is one, wayfinding and mobility is another. And so we see benefits for high vis at all those locations.
Right, thank you. And I think we do have time for this one last one. I apologize, it just came up so many times. I think we covered it at the beginning, but can we give either Darren or another member of the team who might know, give any clues to the audience about when they might be able to get and use the guide we're talking about today? No definitive answers, I'm sure.
Yeah, this is
no definitive answers. We have to go through a clearance process on the final document, and then we have to ensure that the actual document before posting is 508 compliant, and it does tend to take a while. So I'm saying spring, and interpret that however possible, but we are excited to get it up, and we're making it a priority. So please stay tuned. Make sure you're subscribed to the PBIC Messenger. We will try to get the word out as best as possible when it does post, so that people can refer to it, put it into practice, and we'll make sure to have the archive copy of this webinar so people can learn more about it as well.
Great. Thanks, Darren, and all of your work for developing resources like this one. We'll be sure as PBIC to connect you with it when it is available. And the webinar that you just listened to and participated in is being archived, as Darren mentioned. So we'll post we have the slides posted, we'll post the recording, we'll send it an email later today with that information. And we look forward to seeing you all on Thursday. We'll continue this discussion and get a little more in-depth in the research that went on as part of this project. So thanks to Bastian, Mike, and Sarah, and thanks to Darren for his work on this important area. Thanks to all of you for joining us today. Hope you have a good day, and I'll see you on Thursday. Bye, everybody.